Hello, and in this video we're going to be looking at quadratic functions and how to convert those functions into a vertex form so we can find some information about the quadratic. Now this is the general form for a quadratic. f of x equals ax squared plus bx plus c. We have values for a, b, and c. An example would be f of x equals x squared plus 5x minus 6. That would be a quadratic function, and a would be 1, b would be 5, and c would be negative 6 in that quadratic function from this general form. This is the general form, or what we call standard form. So the standard form for this equation is written this way. We're going to convert it to what we call vertex form. Vertex form is where we can see the vertex in the equation. I can't see the vertex numbers from this equation. So we're going to do some algebra to manipulate the equation to change it into vertex form. Now here's some review things that you should know about quadratic functions. Here's the equation again. The graph is a parabola. It looks like this, or it could be going upside down. The vertex at x equals negative b over a, negative b over 2a. That's going to be the coordinate of this point. The x coordinate is going to be negative b over 2a, comma something. We don't have a formula for that, but we can plug that value in here and find out what the y value is at the vertex. If a is greater than 0, that means it's positive. It goes up like this. If it's negative in front of the x squared, then it goes down. Okay, the intercept is always c, so the value of c right here is going to tell you the y-intercept. Now the x-intercepts are found by solving the quadratic formula, but this is called the discriminant of the quadratic formula. If you check the discriminant of the quadratic formula, you can get it to be positive, 0, or negative. You may have no intercepts, one intercept, or two intercepts based upon this discriminant, basically the value that you get out of when you do b squared minus 4 times a times c. If you get a positive number, you're going to get two intercepts. If you get if it gets to 0, then you're going to get one intercept, and if it's negative, you're not going to have any intercepts. It'll be either above or below the x-axis, traveling opposite directions from the x-axis. All right, so here's our first step in changing this into vertex form. We're going to need to know what square binomials are. Square binomials are when you square any kind of binomial, you multiply it by itself. So in this case, this is really x minus 2 times x minus 2, and we would use FOIL or multiple multiplications in order to find this answer. So FOIL is an acronym for this multiplication, F for that multiplication, O is the outside one, that's these two. The inside one are these two, that's an I for FOIL, and then the last two, which is this one and that one, is the last two. When we do those four multiplications, we get this term. Now what we're looking for is how do we get from here to here quickly? Can we relate this value to this value? That's what we're looking at. Is there a relationship between this value, and the value at the end? So can we relate these values here? Okay, if I look at these values, it looks like this value right here times 2 is going to be this value. All right, so if I take this is b again, right? So this value right here is going to be, looks like b over 2. If I take the b value here and I divide by 2, I get the value that's in the square binomial. Negative 4 divided by 2, 6 divided by 2, 8 divided by 2. This is b over 2 there in that binomial. Now if we look at the relationship between b over 2, and the last number, it looks like if you take this value and you square it, so if I take -2 times -2, I get 4. If I take 3 times 3, I get 9. If I take 4 times 4, I get 16. So I think this value right here is going to give you b over 2 squared. And then we're going to use that fact in our process of completing this square, making a binomial a perfect square binomial. So that's what we're going to do next. We're going to take a couple examples here. We're going to look at them and ask you to complete the square. So completing the square is finding that value that we would put here to figure out what square binomial we can create. We're going to want to create a square binomial. So to complete the square, remember, we're going to use that formula, b over 2 squared. So this value right here is b, so we're going to use b over 2 squared to create this value we're going to put right here. So in this case, we're going to use, for this example, we're going to use -10 over 2 squared. In that case, -5 squared or 25. So what we're saying is if we add 25 to this, we can create a square binomial that we can factor now into x minus 5 squared. Okay, this value, remember, is always half of that one. I'm using this formula right here. B over 2 goes here. So B over 2 is this value. So what I'm saying here is this value here, and this one is found by going B over 2. Okay, so let's do this last example with 22 on the end here. So if we use 22 on the end, we're going to add, what is it going to be, half? So 22 divided by 2 squared. So that's going to be 11 squared, which is 121. So we're going to add 121 to complete the square. That's going to be x plus half of this value, or 11 squared. So that's going to be completing the square on that term. So if we have that process down, we can help us find the vertex form. The vertex form is what we're going to use next on this next example. So we're going to transform this equation by completing the square, and then we'll see the vertex, and we'll do another example. This one we're going to start off with a is 1, and the next video we're going to use it as a is not 1. It's going to be a little bit more work in that we have to take and factor out the a. So in this video we're not going to do that. We're going to take a look at this function, and we're going to look at it in terms of the first two terms and the last term. So we're going to group it together, and we're going to put the 1 on the outside. All right, I think I'm going to need a little more room here. Should have left a little more room. Let's try that. A little more room, -1. Okay, now, so we're going to complete the square here. So in order to complete the square, we're just going to take this term. Remember this term right here. Take that term, -6. We're going to divide it by 2, and then we're going to square it. That's going to go there. So we do that. That's going to be -3 squared, or 9. So we're going to add 9 here. Now in this case we have an equation though, so we weren't just completing a square on an expression and doing that. So in this case we have to make sure that this equation stays the same. So that means when we add 9 to it, we also have to subtract 9 so that we don't change the equation. So we're going to have to also subtract 9 here so that we really, in this terms, we didn't add anything. But we're doing this to transform the equation. So let's take a look at this now. We have f of x, and we're going to regroup our values here. We're going to take x squared minus 6x plus 9, and we're going to group those together. We're going to pull the -9 and the -1 outside of the parentheses, and we're going to complete the square on this part. Now that we've created a square binomial, this is just going to be x minus 3, half of this term. Negative 3 times negative 3 is positive 9. So this is what we're going to get. Negative 9 and negative 1 is going to add up to negative 10. This will be our function in vertex form. Now this is in vertex form. It tells us the vertex. The vertex in this case is 3, negative 10. And we'll go over how we find that in the next video. Specifically looking at the vertex, it's always the opposite of this value and this value. This is the x value, this is the y value. And we're going to say it's translated left 3 units and down 10 units. Oops. From f of x equals x squared, which is what we really look at. We look at the transformations that happen to the basic curve. This transforms that by that amount. And we can take a look at that and make sure that that works by looking at our graphing calculator and graphing these two functions. So if we took a look at that graphing calculator and then looked at these two functions, let's see, and we graph these two functions. Let's give it a second to reload. Here we go. And we would plot x squared there to look at that one. And we would plot our other one, which is x minus 3 squared minus 10. All right, and I'm going to do zoom 6 to get a standard window. So here's my first graph, and here's my second graph. So you can see that this graph has been moved over. If we look at it in terms of this, it's been moved over right 3 units. Oh, I did say left, so this is actually right 3 units because it's opposite of the way we look at it. So that was a mistake on my part. This is right 3 units. Good thing we graphed this, right? Because it's the opposite of the negative, so it should be positive. So in the parentheses we do the opposite thing. Just like I said over here, we use the opposite number here, and that's actually a translation of 3 to the right from 0. So we translate right 3 units and down 10 units. So there's our new vertex right there. All right, well, we'll continue this on the next video, and we'll look at this some more.